Okay, we're live.
We're live.
People will filter in and we'll see them pop up. Cool.
Can't deal with the quiet.
Turn on his dude. There we go.
Mikey, we can do this, man.
See people coming in.
Yeah,
Sweet.
it's like Jessica's and it says-
Mountain
Oh
Dew
my
Man
God.
23. I like that.
This is
You should be
Oh yeah, I've got a spot.
All right, guys, welcome to our live. We're going to wait for a few more people to come in before we start. Give them a wave, guys. Nice.
Bring it. You guys might want to plug the mic in.
Yep.
It takes all the fun out of it. They're going to be able to hear us. Oops.
All right, you ready?
Sure.
All right, guys, welcome, Bluon Community. So this topic for this live is going to be about airflow. This is our first segment called Stump, Mike, and Bryan. We're super excited and really curious to see if any of you guys can stump our guys. Between the two of them, they have over 70 years of experience in the field. And before we get started, we want to have each of them introduce themselves and say a little bit more about who they are.
Should Mike go first or should Bryan go first?
After you, Dad.
After me, Dad. Okay, I get it. So hey, everybody. My name is Bryan. I am the director of the tech community here at Bluon. And, you know, this is what we do, man. We're here to help the technicians. I'm one of the gentlemen that picks up the phone, and I use the word gentleman lightly.
Extremely.
I'll now pitch it over to Mike.
How you doing? Mike Mabry, Director of Systems and Technology. And basically what I do is come up with protocols to make things easier for you guys. You know, I'll be one of the people that you're talking to on the phone. You can get me, you can get Bryan. You know, we're here to help.
Yeah, Nate, David, Dennis, Tiff. Yeah, we got 10 people coast to coast, so it is no problem. That 24/7 tech support line is less than a 2-minute wait. That's not a bad deal. So, but we're going to be doing questions,
All right, yeah.
and we're going to try and answer those questions.
Quite a few people emailed us questions, so I'll read those out for you guys. First one's from Nathan, and he asks, can you really have too much return air?
I'll let you start.
Well, Mike and I can battle back and forth on that one. I say yes, that you can have too much airflow, but it depends on the size of the machine. So, if you were to have a upflow or a horizontal, and you had no plenum on it, it would be unrestricted, and it would typically overamp the motor. So that would mean that you have too much return air. And I know Mike's take is on the larger equipment,
Yeah.
so.
I like having a lot more return air because you get a lot more air moving throughout the building. You get a lot more comfortable. You know, so I like more return air than less, but I understand Bryan's point, and I can agree with what he's saying too.
But you're looking at the return air more as an airflow in respective to a building, depending upon your outside air.
Oh, outside air and everything else.
And actually what you're bringing back from the building, or exhausting. If you have a lot of outside air coming back in, then you have to, you know, take into account the exhaust fans and stuff. So you're thinking more commercial, where I'm thinking more of the 5-ton split, that if you don't have a plenum on it, it's kind of like walking up to a 20-ton package unit and taking the door off and watching the amperage go up on the motor. So
I'm talking the ones that you can't open the door when it's jammed.
yeah, it's a little more, a few more inches of static than what you're going to find on a 5-ton split.
Very cool. What do you do if you want to measure airflow at a supply and do not know the open area factor for the grill?
Call an air balance contractor. Just kidding. Just kidding. There are several different vane anemometers you can get, some unbelievably inexpensive, $40 a piece, all the way up to a couple thousand. measure your area, and then turn around and multiply it out, divide it by 144 to get cubic feet, and then take a few readings, average it out, and that'll give you CFM. You know, a lot of people like to look at, well, the blades are going to turn around and cause restriction, and that, I don't think that the little bit of a loss there is going to make a difference for the inaccuracy of the vane anemometer.
And then there's always the hood. So
It's never the right
hood,
size.
Yeah, the hood that you can't get into that space that they've given you. But that's a 24 by 24, which is coned down to a 12 by 12, so it does all the math for you as long as it's calibrated.
Yeah.
So, but yeah, on the residential stuff again, taking a vane anemometer or a hot wire and averaging out and doing the best you can for the area that you're working in.
All right, cool. Brian, did you get a question mailed in? Do you want to answer that?
Yeah. A gentleman by the name of Bruce, and Mike hasn't seen this one yet. So Bruce writes, last spring we replaced a 25-ton rooftop with a single-speed blower. The duct system had motorized bypass dampers and approximately 7 VAVs on it. They've since changed it to a 25-ton with a VFD, and in spring they were having problems with the machine frosting up.
Okay.
In the summertime it worked fine. So his question is they had an idea of actually running a static pressure control directly to the VFD, and then his question is, do they leave the bypass closed, partially open? Right at the moment he has it locked at 10%, and he has the minimum speed on the VFD at 50 hertz. So I'm sure you and I can come up with a bunch of different scenarios, because I hear, and I'm going to use the term, makeshift VAV. Yeah. So it depends on whether it truly is a VAV with minimums, or if it's a motorized damper that can go 100% shut. So
I think one of the, you know, I like the idea of going to a true VAV and getting rid of the bypass dampers, because I hate bypass dampers. So if I got a 55-degree leaving air and I'm dumping that right back into the return, that's not a good thing for the system.
It's going to freeze it up,
yeah,
or flood back the compressors.
Yep.
So.
But the problem is that if it's a 25-ton system, and depending upon how many stages we can step down, you know, and what we can do with the cooling that we have available, I mean, if we had a nice variable linear load type thing, we could match it all the way. But
he said in his write-up he's got it's 2 steps.
Okay.
So it goes from 70% to 100%. So.
Okay.
I'm sure in the spring when they were dealing with light loads, the bypass damper was opening up quite a bit on him.
Yeah.
So I like his thought of hooking up the VFD to static pressure.
Yep.
My concern is, like I say, I'm used to seeing the makeshift VAV systems go in and they use the bypass damper and they all talk to each other. If it's truly off of static and the VAVs are true VAVs and have a minimum position, I think just putting a static pressure transducer on the VAV to maintain the supply static, and then setting up something for his supply air.
Yeah, one of the huge problems, and it's a huge misconception, is that static pressure equates to airflow. So, like, you know, if we had the dampers 100% closed, we can generate 10 inches of static pressure if the fan would do that, and move 0 airflow.
Right.
So the other problem comes into play is that if we've got the dampers at a minimum and we're continuing to force cold air in there when they're trying to shut it down, you're going to overcool the space and have a problem there.
So here's a stupid example, but it will hopefully trigger a light bulb for a lot of you guys. If you blow into a Coke bottle, you build a lot of static pressure. Okay. Maybe that scenario didn't work for you. How about blow up a balloon?
There we go.
You blow up a balloon, you've got a lot of static pressure built up into the balloon, but you've got it pinched off and you've got this huge balloon. You've got static pressure, but there's no velocity, there's no flow. Right. So now you open it, now as you open the balloon and it's making the squealy sound, and you know everybody loves that, and let it go and let it fly around the room. Now you have airflow, which is making the balloon move. So You can have dampers at 50%.
Right.
And if you, on a constant volume system, if you have dampers at 50%, your duct static pressure is up, which means that the noise level is going to be higher.
Yep.
Whereas when the dampers open up, your static pressure comes down and the noise reduces.
Yeah, I mean, there's a couple things that could be done with that. Like a two-stage stat where you could kind of play with your differential a little bit, because as you turn around and let your supply air increase in temperature a little bit, it's going to cause the zones to open more, getting a little bit more airflow, which could be helpful.
Don't get us going into perimeter and exterior. All right. Interior zones, exterior zones.
But no, I mean, the whole thing is I like the static pressure part of it, and with a little bit of control, you could do some really nice things. And you know, if you got questions, give us a call. I'd love to talk through some of that stuff with you.
On the 24/7 tech support line?
Mm-hmm.
Less than 2-minute wait?
And if worse comes to worse, I can give you Brian's phone number.
It's in the lower right-hand corner of the app.
All right, so we got a question from Nick. He's asking, Hepa filters versus electrostatic filters with UV.
It depends on the system. Some systems need all of that. If you're working in a hospital, you're going to have UV lights, you're going to have HEPA filters, you're going to have bag filters, you're going to have pre-filters. But the key to whatever you're using is, oh my gosh, being able to ramp a fan to maintain the airflow. Because obviously, as your pre-filters get dirty, you're going to need more volume
To overcome it.
to overcome it.
Yeah, one of the things that comes to mind on that, I hear all these people talking about, you know, going to these higher rated MERV filters and everything. Most of the HVAC equipment that is in residential, it was designed for that little 1-inch fiberglass filter, and that was it. So now let's put a turnaround and put a big filter on there that's got a heavy pressure drop.
Yeah.
So now your 5-ton unit's got enough air for a 2-ton. It's going to cause your coil to freeze up, or you're going to have to undercharge it to turn around, and so you're not freezing up. So now your 5 tons, a 2-ton. You know, so I think there's a huge problem.
So in the case of, again, I beat up residential. You seem to beat up on commercial. On the residential side, if you had an option of going with a 1-inch pleat or putting in an electrostatic, the electrostatic is probably going to do the same amount to clean the air and not reduce your airflow. Whereas the 1-inch pleat, and I'm guilty of this because I got 1-inch pleats in my house, but I made sure that the surface was large enough I didn't lose capacity.
You know, if you take one of the fiberglass filters and just leave it in a real long time, it gets a lot more efficient. Just kidding.
Yeah, it collects more
That's
dirt.
called plugged.
Thanks for the question.
All right, HVAC guy from New York says, on all the gyms in my area, they now require MERV 13. Do you have a comment on that?
I do.
Poor guys. Go ahead, Mikey.
I do. You know, ASHRAE is pushing more outside air, better ventilation, because, you know, if you look at the N95 masks, which are, you know, 95% efficient, it says doesn't protect from COVID. So I don't know that the higher MERV rating is really going to do any good. I would rather see higher outside air to turn around and get better ventilation and everything. So that would be my suggestion.
But we can't fight the politics of they're requiring some of these guys to go in with these heavy filtration machines, and
ASHRAE's kind of the final word.
I get that.
Yeah.
It's the political end of our trade, and you know.
And we all know I'm not political.
Where's my seatbelt?
You said I had to be good tomorrow, right?
Yeah, you have to be good tomorrow. It was actually today. You can go back to be a Mikey.
Damn, I missed that one.
You can go back to be a Mikey tomorrow. Or you can be Brian tomorrow. Either one. I'm fine with it.
I'll get you in trouble.
Okay, next one from Nathan. What's the best way to calculate anything over 25 feet, we have to increase the flex size, but no one knows how much 7 inches needed on a run of 6 inch that is over 25 feet.
Let's take what he's really talking about there. Flex duct is terrible because it's not real smooth on the inside, so you're creating friction losses all the way down. So in California, they've done away with a lot of the flex duct other than the last 3 feet to get away from a lot of the friction losses. So I don't know that there's a per se calculator, but keeping it nice and tight and nice and straight is going to cut down on the friction losses in there. I've always liked oversizing the ductwork just a little bit because it's also quieter for the supply air grills.
And the same on the return side.
Yeah.
But like Mike said, here in California, which is where we're based, having that calculated out, because they do calculate, and it's I know it's in the engineer's books, and I don't have an engineer's book in front of me, but it will tell you the feet loss due to
Right, but that's going to change drastically if they got one scrap every 25
oh no,
feet.
but that's why California did what they did,
Yeah.
is because now they can actually measure the velocity restriction per foot and what they have to do, because you don't see a 20-inch going all the way.
Right.
It's tapered down.
Right. You got to keep the velocity up and everything else to move the air.
Right.
You know, it's funny because I don't agree with a lot of the things California does, but to turn around and fix the ductwork in the attic.
Back on, guys.
Yeah. To fix the ductwork in the attic, to fix all the leaks and everything, to actually get the nice cold air to where it needs to be instead of leaking in the attic and everything else.
Yeah,
it's
yeah.
huge. I mean, it's a huge energy saver, and I mean, it was a lot of guys complained when they did that, but I thought it was a
That's one of the good things that they did.
it was definitely a good thing that they did. So,
Yeah.
okay, California, this is a once in a lifetime thing, so enjoy it.
You've done good.
All right, so we have a question from Call Classic Air. He's asking, thoughts on ducted mini splits installed in attics in Dallas, Texas?
I do chillers.
Well, yeah, ducted mini split. I mean, you got to follow the instructions if they're going to tell you what your minimums are going to be. I know on the Mitsubishi City Multis, it's even all the way down to calculating the amount of refrigerant in the system. You need to know all of your line lengths, what your elbows are. It all adds up, and then they tell you in their calculator, or the designer will send that information to you and tell you how much refrigerant you've got to add. So pretty much it's designed out for specific areas and zones, and
You start throwing restrictions on there, you're going to change your airflow, you're going to change a lot
yeah,
of things.
if you oversize it or undersize it from what they're telling you to do. I have not. I mean, I retired 3 years ago after doing 38 years in this trade, and that was huge, and it was specific. They would send you a packet on a building and tell you what you needed to do with it.
Yeah.
So.
Guys, any more questions? Get them out there. Anything about airflow? Anything you've ever wanted to know?
I'm gonna drink some more tea.
Okay, we got one from HVAC Guy in New York. He says, would you guys be willing to answer a question on chilled water?
Sure.
Why not?
All right.
Have at it.
I'm sure the answer is it's cold.
All right, we're ready for you. All right, do you have any questions in the meantime or topics you want to throw out there that people
Well,
should
you know, yeah, I would like to. We got a minute while they're doing this. I've always, and Mikey's always picked on me, because I've had to do things on the fly, right? Rube Goldberg things. And I had a digital thermometer that read wet bulb, dry bulb. Mikey knows already where I'm.
Dry bulb.
That only read dry bulb. So I took my $20 friggin' pocket thermometer and put a shoestring on it, and then wet the shoestring. And you know what it does? Tells you wet bulb temperature.
It does.
So why does that matter? If you look at some charging calculators that are on the condensing units, it asks you for wet bulb on the return air. If you look at the Bluon app and you look at our airflow calculator, it's going to get you really close, but you need to know wet bulb return and wet bulb supply and the tonnage of the machine you're working with. So if you're stuck and somebody ran over your digital thermometer that does wet bulb, dry bulb, or a sling psychrometer as we used to
Us old guys.
use, you can get away with a standard probe and just use a wet sock or wet shoestring. Wet sock, wet shoestring. It's all cotton.
Right, so from now on, you guys can just repeat my questions so they can hear it clear.
Okay.
So someone asked, thoughts on air changes per hour requirement?
That's
Changes on. I'm
Air
sorry.
changes per
Air
hour.
changes per hour.
Yeah.
That requirement is depends on whether you're in a hospital, a house, or a commercial building.
Yeah, it depends. It depends on what you have in the air. I mean, I remember back in the day when the stealth fighters were just coming in, and they pulled 100% outside air, went through a whole bunch of stuff, dumped it in, and took it right out through scrubbers because of the contaminants and stuff. So there were no air changes. It was all 100%
Again,
outside air.
we deal with Title 24 here. I don't know all the laws for the rest of the states, but Title 24 here has just increased it. We got to have a minimum of 20% outside air. And then you get into the Title 24 stuff with the VAV and the ECM motors. Now you have to go in, and not only are you setting up your ECM motor, but you have to set the outside air to adjust for when the ECM motor is on heating speed or cooling speed so that you maintain that 20% at all times.
See, one of the things that's really cool about that, and I know I was working with it before it came into play, was they said you had to have so much outside air per square foot.
Right.
And this is when we were starting to go to the CO2 sensors, to where we could actually do more of a demand control ventilation.
Yes.
So now if the CO2 levels went up, we could bring in more outside air. But if the CO2 levels were down, we could decrease our outside air because we were maintaining. We're actually measuring the CO2 in the air. So, I mean, they're getting a lot smarter.
Yeah, in a commercial atmosphere, you go into a conference room is empty 50% of the time. And then you pack in 16 people, that machine's going to open up the outside air damper when that level starts to rise. So I hope that answered your question. Sorry. It's it varies so much depending upon what you're working on.
All right, we've got another one. Running 3 35-ton chillers for cooling a radioactive pool. At what temperature is it ideal to cut in dry cooler? And would you stage the fan control on the cooler 12 fans to be exact?
Oh, that's all Mikey right there, and that's a big design sequence that they just throw at you. So you've got 12 stages of fans. You've got some type of material I heard was radioactive, a radioactive pool. You have.
They're trying to cool the pool.
They're trying to cool the pool.
Trying to maintain temperature in there. My VFD history and everything else is going to say I want to put a VFD and run all 12 fans at the same speed.
Same time, and just ramp them up and down, right?
With the dry cooler, it sounds like you're doing something with evaporative cooling there, of sorts. A lot of those dry coolers used water flowing over the tubes.
Now you're thinking evap.
It's a form of evap.
Yeah. But a dry cooler Well, we'd have to go back and ask him. Are you actually looking at a dry cooler, or which is air over tubing, or are you looking at evaporative, which is water over a bundle?
Well, you remember they had those ones that the air was going through the tube, and the water was going over the outside of the tube, and they were getting a transfer through the tube wall to get cooling there.
Yes.
So if that's what we're talking about, you've got to look at enthalpy. You've got to look at a lot of stuff there. But I mean,
he said he was in New York.
If you want to have that conversation, give us a call on tech support. Ask the guys to get you through to me. I'd love to talk to you. I've got probably more questions for you to find out exactly where you're going with this. But I would definitely enjoy speaking to you about it.
All right, we got one. What is a rule of thumb to check charge on a heat pump in heat mode?
I'm going to get myself in trouble on that one.
Can I watch?
Yeah. The rule of thumb on that is put the machine in cooling, check your charge, and then turn it back to heat.
But I think, and I'll go one step further, because heat pumps are not my big thing, and a lot of the smaller systems that had cap tubes and pistons and everything else.
Yeah.
But with the charging charts that they put on there, you get yourself a decent set of psychrometers and charge it according to the manufacturer's recommendations. I mean, they went through and calculated all that stuff. So I would go to that.
Yeah, and me being the smart aleck that I am, I threw that out first to put it into cooling. But a lot of them, when you take the panel off the machine, that is their recommendation. Their recommendation is only charge the machine in cooling and then turn it back to heat. So there's really no rule of thumb on that in some cases. And then some of the machines have the charging charts right on them for both heating and cooling.
Well, it's like you read a lot of the bigger equipment manuals and stuff, and they say don't charge it unless you're better than 65% relative humidity. I'm still waiting to charge one in California.
All right, so we got further clarification on the one from HVAC guy in New York.
Yes.
It was a fluid cooler and to use outside air to chill water.
Outside air to chill the water. Okay, so it was exactly like you're talking about, where they're
wet
taking.
bulb
they're
is
taking.
going to be important.
Well, no, they're taking. The water is in the tube, and they're moving the cold air in New York across that to chill that water to send it. Dry cooler.
Oh, okay.
Dry cooler. No water in the tube.
Yes, I mean.
You still. There's still. We got like 4 pages of questions to ask you. So appreciate that.
Well, I mean, like for
call
example,
in
Reno. I mean, and in Vegas, I did one where we had condenser water that was like 40-something degrees when it was 90 degrees outside, because the relative humidity was about 2%.
Right.
So there's a lot of stuff that can go into that type of calculation in that.
But we'd love to get deep into the weeds on it. I'm sorry.
Yeah.
This is.
I love that
We're
stuff.
not going to get deep into the weeds today.
All right, we got another one from Boy Wonder 5, and he's asking, how do you size up how much return air you need per room? I'm used to doing 1 CFM per square foot of supply air into a room commercial building.
I've always used 400 CFM per ton. Measure your room. If you're putting a return duct in every room in an office, if it's a 20 by 20, do the math. It's 400 CFM per ton. Size it even for the return. You just on the ductulator, you're gonna, instead of using 0.75, I think you go down to 0.5 and size it from there.
Yep.
Alright, let's get some more questions, guys. Anything about airflow?
I think if we're still waiting for questions, one of the things that, and Brian and I were joking around because we were talking about some of the tools that we're doing testing on and everything, and I broke out my old sling psychrometer and you get the stupid thing, you got to find some distilled water, and then you got to turn around, swing the thing off, and young people look at you and like, are you crazy? Then you got to take, your wet bulb, dry bulb, put it on a psychometric chart, do all your calculations and everything. There's some really, really cool tools available now. Fieldpiece makes some really good ones for electronic psychrometers, and they're probably $100 or less, and they're just really amazing. So for you old guys, you know, come out of the dark ages, you know, put away the Cooper pocket thermometer.
Really, dude, you're going to make me throw my mercury thermometer away after all these years I've saved it.
You break them over and you freeze it and you kind of play with it. And say, oh, that's right, you're not supposed to do that stuff anymore, are you?
No. Put my seatbelt back on. Not dating myself. I didn't have a mercury thermometer. I had the one with the red dot.
Red alcohol.
Yeah, that's it.
That's where the alcohol went.
And I didn't work on arcless.
Okay, we've got another one. What causes condensation on supply air vents?
The air vent is below the dew point. The air coming out is below the dew point, and allowing for condensation.
The space is high, which is what's going to cause that. So how do you fix it, I think, is the better question, which is dehumidifier. Again, if you're dealing with the residents, they are going to have to run the machine longer at a colder temperature to dry out the space. So I've seen that a lot in our beach communities where the humidity is up and all of a sudden they get a blast hot day. Our beach communities down here are very temperate, but they'll get a blast hot day and they'll turn the air conditioners on, and just from it being a 75% relative humidity space, 60% relative humidity space, now you've got that cold air going across the grill and it's just condensing like a Coke bottle. It's, you know, you take a Coke bottle out of the fridge, put it on your counter, it's going to sweat. And it's the same thing with the supply grills.
Yep.
So once they dry out the space, that'll go away. Sorry, that's the way it's, unfortunately, thermodynamics works.
All right, we have one from A-Team HVAC, and he's asking, what happens to TEL of fittings when you have oversized duct?
The TEL of fittings with
Total effective length.
oversized duct. So, first of all, if you've got oversized duct, it's going to reduce your pressure,
It's going to lower your velocity.
which is going to lower the velocity. So now you have oversized duct, and you've got your total length of the elbow. It's going to make that total length smaller, but the effect is going to be multiplied because you're already oversized.
You have trouble getting the air delivered.
And by the time it gets to the end of the run, it's probably going to be a whisper.
Yeah.
Or my old man used to say, a fart in the wind. It's just like not a whole lot of air coming out.
All right, another one from William, and he's asking, what would cause emergency heat to blow cold air?
Well, sounds like a heat pump question. You want me to take that?
Yeah, you can have that.
So, emergency heat typically is electric strip heats coming on at the time that the heat pump goes into defrost. So if your heat pump goes into defrost and your strip heat comes on and only 50% of the strip heat is working, then there's not enough strip heat to overcome the cold being generated by the system switching into cooling. That would, and if you're putting it into emergency heat at the thermostat, which means that you're locking out the mechanical and strictly bringing on the strip heaters, then more than likely, if you've got cold air coming in, you got duct leaks or you've got a lot of bad elements in your strip heater.
All right, any more questions? Anything about airflow? We're ready to answer them.
So yeah, you just talk about my old history and the crap that we got ourselves into with all the stuff you had said today that we've got. You know, the digital stuff that I purchased 20 years ago. You know, state of the art stuff, and it's like, but it was expensive as all get out.
Very.
So looking at it today, the technology is so much more improved, and it's a whole heck of a lot cheaper. VFDs.
Oh yeah.
We refer to some of those as disposable now. You go pick it off the shelf, throw it in. If it burns up, bye-bye. You just go get another one.
Yeah.
Not talking about converting a chiller, over to a VFD from the old clappers. And
one of the things that I really like, and I mean, I'm an old guy. I mean, I'm actually older than Brian, and we used to have to carry books for everything. And
he
nowadays,
didn't. He used a chisel and a hammer.
I did. But there are so many apps out there. There's duct calculators. There's airflow calculators. There's a lot of these things that, I mean, are a buck or two or free.
Right.
That can be very, very helpful to you. So, go and look at that. I mean, look at the Bluon app. I mean, we've got an airflow calculator in there. We've got subcool superheat calculators. We've got a lot of stuff that could be really, really helpful to you guys. And, all else fails, give us a call. I mean, we're here to talk to you. We're here to help you. And I'm going to make a special plea to the young guys. Give us a call. Don't be afraid to call, because we want you to get better. We want to help you
Right.
to go to the next step. And
I love talking to apprentices. I've said this to a lot of people because, for those of you that aren't aware, we have an app. The app is free. You download the app, you call, talk to me, talk to Mike, we'll give you a code, 100% free. But a lot of guys ask me why we're doing this. Why are we offering something free? It's like too good to be true. And it's, I told you, I've been in the trade for 40 years. I was an instructor for 25. I'm back here as the director of the tech community. And I love to give back. And it's not that I don't understand the joke, and I can take a joke, but I look at questions on social media, and I know the joke is just replace the TXV. But if that guy on the job really needs some help, if he's really stuck, then we've got the app 100% free, 24/7 tech support. I know I keep beating that up, but it's true that we want to give back to our trade, and it's call us, we'll laugh, we'll joke, you're frustrated, I will get you off the fence, I'll get you back down in front of the machine, calm down, and we'll troubleshoot it. I'm going to make you start from the beginning, but we'll find the problem. I've done it at 2 o'clock in the morning, I've done it at 4 o'clock in the morning, I've done it at 3 o'clock in the afternoon. It's what we do.
Yeah, and it's not off a script. Did you check and make sure it's plugged in?
Yeah, I have had questions. As a matter of fact, driving home last night, I had a kid call me, and he was an apprentice, just starting out. He'd probably less than a year in the trade. And he says, the board is telling me this code. It's like, okay, what's the code, and what's the code telling you? He says, it says the polarity is wrong. And I said, okay, I'll plug it from the wall. Take your black and white wire and switch them, plug it back into the wall, and something as simple as that.
We're here to help you out with it. So,
one of the things I get a lot, Brian, is when I talk to people, they'll turn around and they'll lay out the whole scenario for me. Okay, it's doing this, it's doing this, it's doing this, and they'll do a very nice job of painting this picture.
right.
And then they go, okay, it's okay, I figured it out.
Yeah, now we got it.
Because they're taking a minute to think it through and present it.
Right.
And I mean, it's a
Well,
lot of times it's just having somebody to talk to.
Yes, exactly. It's sometimes you're stuck on a job, you can't see the forest for the tree. And I've had plenty of those scenarios where it's like the guy calls and he's frustrated, and it's like, first of all, I got to get you unfrustrated, which is sometimes challenging in itself. But then it's like, all right, send me a picture of what you're looking at. I've got the wiring diagram. I've already looked that up. So he sent me a picture of it, and it's like, unfortunately, it's right in your face. You need to unplug that, move it over to the other side, unplug that. It's like somebody put the control wires on, instead of making a circuit, it was going nowhere.
Yeah.
So it's like, I could see it in the picture and he couldn't see it. And it was just because it was frustrating. He was second guy into the job, et cetera, et cetera. So,
All right, good. We got another one from HVAC Know-It-All, and he asked CFM/ton in dry climates versus humid climates.
oh, good one. And that, again, I hear a lot of rule of thumb. And in the drier climates, it's 400 CFM per ton. In the more humid climates, it's 350 CFM per ton. And the next question would be why the difference is if you slow the air down, and it might help the guy that had the sweating supply grills, if you slow the air down, the coil has a chance to absorb more moisture out of the air, therefore drying the space faster. Thanks for the question.
All right, so someone asked, hey guys, I'm relatively new to the HVAC field, and I've been having trouble pulling a deep vacuum. Any advice? I make sure there's no leaks and do a triple sweep. Nothing seems to help. Thanks.
Oh, I want this one.
Okay, Mikey's got this one.
I was on a project with a journeyman that probably had 20, 25 years. And he's got this really nice vacuum pump, and he's pulling the vacuum through a set of manifold gauges with core depressor, Schrader core still in, and he's fighting it, he's struggling. And I says, hey, let me use my True Blue hoses or my Appion Megaflow hoses. I pulled out the Schrader core, I connected it, and it pulled right down. And he goes, I gotta go get new gauges. I gotta go get a new vacuum pump. I gotta go get this. It's funny that when you try to pull through a Schrader core, it's about 0.2 CFM that you can pull through there. So you got this really, really cool 12 CFM pump, and you're restricting it to 0.2 CFM because of the Schrader core and the core depressors.
Yeah.
So
restricted.
yeah,
So restricted.
Get rid of those there, get the Schrader cores out of there, go to vacuum rated hoses. You know, I don't know why you're pulling through a manifold, because that's just more places to leak.
And that would be the other thing too. If you know your system's tight, which it sounds like you've pressurized the system and checked it 3 times. So you're either pulling through a standard manifold hose, which is a charge and test hose, not a vacuum hose. Your O-rings are leaking. Your manifold is leaking, or it's just as simple as what Mike was just trying to explain. In this particular case, bigger is better. So you've got the True Blue hose, the big hose, and you take the core out, and yes, you have that restriction right where the core was, but it is like a roadblock on the freeway.
Yeah.
You take it down to 2 lanes from 5, and then open it back up to 6. And as soon as you open it back up to 6, man, do you get a lot of flow.
Yeah.
So,
you know, another thing, look for stupid things. Look for valve packings and stuff like that may be leaking, because, you know, and I'll go off on a tangent here, but I don't know how many times that people turn around and go to a valve and they don't back the packing off. And so every time you screw that in and out, it wears the packing and it's going to leak. So back the packing out a quarter turn, screw your valve in or out, and then tighten the packing back down. Put caps back on. And I think one of the things that drives me nuts is I cannot stand seeing these damn plastic caps that come off refrigerant cylinders and they're put onto a system. It's like, no. Put on a good brass cap that's got an O-ring in it, and you're golden. And stuff like Nylog and stuff like that.
but again, Mike, we're old school.
Yeah, we
It's
are.
that extra little thing that we do to prevent callbacks.
That's for sure.
All right, we got one from A-Team HVAC, and they're asking, what is the biggest mistake you see with a duct design?
Undersized.
I would say running the flex duct through the attic, and it goes like this.
Well, yeah, you got the snakes.
Yeah, you got the snakes. You know, they hold it up there with a piece of wire instead of a piece of strap, and it's just digging into it and restricting it.
Yeah, if they just take it and you know, and what just comes to my brain is the attic. You know, they take and throw the duct, and it's doing that snaky, snaky piece through the attic. It's like, how do you get any velocity at the end with all of that restriction going on? I do. I had a tech support call coming in. And doggone, somebody else picked it up. Okay, well, at least it got picked up.
You know, one of the other things too is, you know, Brian's got 40 years. I've got 47, 48 years now. I know nothing about mini splits. So if you call on a mini split, I'm going to get you over to one of our guys that really knows that kind of stuff. I mean, I've worked on the 2,000 ton chillers and big systems and everything else. So we have a lot of different technical people that cover the full gambit. So, you know, we're here to help, and give us a call.
Yeah, it's real easy. If you guys that are watching this, if you're not a member of the Bluon community, it's super easy. Go on to whichever platform you're working on. If you're working on iOS or you're working with Android, go into your respective stores and just download the Bluon app and follow the simple instructions are, hey, look at what you've downloaded and then give us a call for a code and you're in. You become a Bluon member forever. And as the more people we have on the app, it's going to be free forever.
All right, we got a comment from A-Team HVAC, and they are asking, will one of you guys come on the HVAC Overtime show to talk tech?
Oh, hell yeah.
Oh yeah, in a minute. In a minute.
All right, we got another one from HVAC Know-It-All, and he's asking, how do we check total external static pressure of an air handler? He's trying to stump you guys to see if you can do it.
You know,
That's not going to stump me.
no, I just, you know, and I'm gonna plug Field Piece. I just got a set of the Field Piece manometers.
Right.
And your total static is from the return to the supply.
Yep.
You're looking at the negative on the return and you're looking at the positive on the supply. And that gives you total system static.
Kind of like calculating total capacity. Latent versus sensible gives you total.
You know, the hard part though, that latent's hard to see.
I know. But with a proper thermometer.
There we go.
Or a shoestring.
There you go. You and your shoestring.
Thanks, Gary. Appreciate you, man.
All right, so they haven't been stumped yet, so let's get a question that they cannot answer. Come on, guys, make it hard for them.
Nope, not yet. Are we wearing you out, guys? Huh? How many thumbs up have we got?
Quite a few.
Huh? Do I have any hearts?
Yeah, you do.
You know,
I want to feel the love.
You know, I mean, we're talking about airflow. You know, the one that comes to mind is never to get all the air out of the compressor and then turn around and apply power.
Oh no!
It'll
don't.
do nasty things.
Oh yeah.
You just got a bunch of hearts.
That is a storm.
Wow,
at sea.
lots of hearts. Lots of love.
You know, but bringing that up,
Yeah.
and I know this has nothing to do with our airflow topic.
But you're pulling all the air out.
Yes, we pull all the air out. There is a difference, and I've had some older mechanics, seasoned mechanics, I guess is the better way of saying it,
It's a polite way of putting it.
that work on chillers and are afraid to energize because the machine is in a vacuum when it's fully charged with refrigerant, which is totally different than having a mechanical vacuum, which is a total void between the electrical and the ground source. Whereas when you have, and I'm talking about an old R11 chiller, so when you've got R11 in there, even though that particular refrigerant is in a vacuum, especially when the machine's off and it's less than 72 degrees outside, it'll be in a vacuum, but what is surrounding the motor is still, there's molecules there, it's still an insulator.
Yeah.
So the one thing that you never ever want to do is take for granted that I'm pulling a vacuum on circuit number 1 on a 2-circuited machine, and I can run number 2. Yes, you can run number 2 if you have no power going to number 1 while you're pulling the vacuum. And as you guys know, there's a lot of manufacturers out there that to cut 5 cents, instead of having a 3-pole contactor, they got a 2-pole contactor, which means that one leg is always hot. If you energize that machine while circuit 1 is in a vacuum, you've now blown up that compressor because that hot leg will go to ground just like that.
All right, got another one from HVAC Know-It-All. He's really trying to stump you guys to see if you can do it. Difference between static pressure tip and pitot tube.
The pitot tube and the static pressure tip, the difference between
Static pressure tube is taking a single point. A
Yeah.
pitot tube is taking a differential,
Yes.
and typically you put it into a slide rule type calculator, and that pressure will give you an air velocity.
Yes,
A
'cause
velocity of pressure.
one you're using to tell the difference between, like, for example, across the filter, that's going to be pressure drop.
Yeah, which
And
can
the
be
other
two
one,
statics.
the pitot tube, is going to go in the direction of airflow. So my pitot tube, so that it tells,
The pitot tube has 2 takeoffs
yes,
for calculating velocity pressure.
right.
But then again, that's so old school. You know, now we just use a hot wire or a vane anemometer. Life is good.
All right, we have another one. How much CFM per outlet on a space pack system?
All right, we may have a winner. Space pack system.
Yep.
I think I would ask, can we be a little bit more?
More specific
Generic
on the space
onto
pack
that.
system.
I mean, we did have one of our guys turn around and took a call because they had a unit they thought was in Russian and it was Ukrainian, and we got them through. So help me out with this one here and tell me what we're looking at.
All right, we have another one from Boy Wonder 5. They're asking, what's the formula for sizing up a bigger diameter motor pulley if motor amps are needed?
I unfortunately suck at formulas. You call me on the phone, I have it in my computer, I can tell you what the fan speed formula is. It's motor speed, and driven and drive diameters.
Yeah, but it's also going to have to do with your fan curve and everything else.
But he wants to up the amperage on his motor, so you go to a bigger pulley.
Right.
But it's doing the calculation to know, and I've got that written down.
But you can also run into that depending upon your fan. As your fan curve changes, you're going to turn around and move more air, and your
Yes.
amperage is going to go up account of that. So I think you need a few more factors for calculating that.
But we can calculate your RPM. That was
definitely.
what I was getting at.
The ratio for that, yeah.
Yeah.
Come on, Gary, you got to have a good one in there. Come on.
All right, we're gonna wrap it up. If you have no more questions, last chance, get them in. Anything about airflow you've ever wanted to know?
I mean, come on, guys. I put shoes on.
It's okay, Fred.
Well, if there's nothing else, I do want to say again, if you have questions, please give us a call. We're here to help. And you know, Brian and I are joking and kidding around and having a good time with this and everything else. But if you call, you know, we take.
I'm gonna laugh. I'm gonna joke around, but we're gonna get you through it.
Yep.
We've been there.
Yeah.
We've both been on a roof in the rain at 2 o'clock in the morning, trying to figure out what the hell's going on with that machine. and wished we had somebody to call.
Except we didn't have iPhones back then.
No, no, you had to climb down off the roof and go find a payphone that hopefully somebody didn't stick bubble gum on. But if you guys don't know what a payphone is, Google that shit. So everybody out there has the app, or everybody out there is going to have the app, because we want more people.
Yep.
100% free. Tech support, less than 2 minutes. Over 35,000 pieces of equipment with all the manuals. We've got calculators. We've got tips and tricks. The gentleman that asked the question about pulling a vacuum, we have a best practice in our app, which goes to a video, and we talk about how to improve your evacuation times. We have how to improve your recovery times in the app.
Yep.
And how do you get the app? Download it at either one of your stores, absolutely free. You'll get access to it by calling me, calling Mike. Just click on call to get the code.
Right, cool. So if anybody watching, we're going to try and do these lives more often. So if you have any ideas for the next topic, be sure to DM us and we'll look at those. So yeah, thanks for tuning in, guys. We were really excited about this.
Keep those cards and letters coming.
All right.